This is Alex Larsky's recording of Assignment 4 for Dewan's 533 class. So for the first component of the demo, I have to show the explicit receive semantics of my custom server and client input ports, and also set them up in a way such that some receives never unblock. So you can see in my custom client, I turn on object trace utility and set my custom input port factory. So what I'm going to do is run a server and two clients in debug mode. So now in the server, we can see that receive was called before any messages have been sent, so it'll wait for a message from anyone. So if we go into one client and send a byte buffer, then in the server, we'll see that a message is from client 1 is being queued into the general queue because no one is waiting on, or no server is waiting on, or no thread is waiting on a message from a particular client. And then after that's queued, the message will be dequeued from the general queue, a message from client 1. And now when the client goes to wait again, it's going to wait on a message from client 1 because that was the last sender. And when it does that, a queue will be created specifically for client 1. Let's see what else. And we can see here, before we move on, that this message was received, first a byte buffer was sent, and that was received in the little loop here. So now we'll have the client as an object and see something similar. So again, we saw the receive was called on client 1. Now when this message comes in, we will queue that message in the queue for client 1, this to object, and then we'll dequeue the message from client 1's queue. So then again we see receive the message from client 1 2, and then again when the server calls receive, it will be on client 1. Now in the client we'll do the do operations, which will both increment and get the value. Scroll up here. So here's what we just called receive. You'll queue the message in client 1's queue, a serializable call to increment. Then we'll dequeue from client 1's queue. See we received that message, and now we'll call receive again. Queue up the serializable call to get value, dequeue it, say that we received the message, and when we call receive again, we'll say we're looking from something from client 1. So now this client is all done. But now this client, no matter what it sends, we send a byte buffer, we can go to the server and see that we received a message in our custom notifier from client 2. We're queuing it in the general queue, but because the server called receive without parameters accepting from the last sender, it will only receive from client 1. So it's blocked until a message from client 1 comes, no matter how many things this other client sends, all of its objects and operations. We can see, this is the client, sorry. If we go to the server, we can see that we're queuing a message in the general queue from client 2, a byte buffer. We can also see that we're queuing another byte buffer, a serializable call to increment, and a serializable call to counter. And those are all in the general queue and are not going to unblock here because the server specifically waited on client 1. So I believe that should cover everything from the start. Yep. Okay, now Now as for the second part, I have to show the custom tracings in the correct place in the client. So you see a client here, starts, creates a queue for receiving general messages, because as a client it only has one server and only needs one bounded buffer. So we see send the 2, we send the call to increment 1, but down here we queue the message in the general queue. It's coming from the default server and it's RPC return value of 6. And then we dequeue the message from the general queue from the default server, and we have received that message. So similar semantics. So now for part 2, I'm going to demonstrate parts 2.1 and 2.2 of the synchronous call. So we no longer need breakpoints here or here. Oops. But we do need breakpoints on increment and get value. And in the client, we now need to turn on the RPC. Oops. The RPC trace utility, our asynchronous received call invoker factory, and our custom sent call completer factory. So we'll start up the server. And 2 clients. So we can see that the server has stopped on the breakpoint in increment. We see that the receive call was made, but if we go to the client, we can see that wait for return value and our custom call completer was called, and then receive was called on the client input port with the source default server. So inside the client, after we sent the serializable call to increment, even though there is no return value, it is still synchronous and waiting. Okay, so now if inside the server we let these increments go through, and we go back to the client. Let's find where this is. Okay, so here we're calling get return value, wait for return value, and then receive. Now we get an RPC return value of null because it was just a procedure value. Processing return value. And that's about it for that. And now we can see that get return value is called again, wait and receive, because we also blocked on get value. And if we let the server execute, go back to the client, we can see we called receive, then we received our RPC return value of 12, RPC return value 12, returning, so. Now, so that shows that when the server hits the breakpoint increment, the client is blocked, so it's synchronous. We showed that wait for return value gets called, and that calls receive. So now inside of return value received, in our custom sent call completer, we can see that we no longer call super to in-queue the message because it is handled by the queues underneath with receive. So all it does is tell you that the return value is received. And I'll show the override handle procedure function or procedure return. So I basically looked at this handle function return and stripped out what I needed, which basically makes this reply call providing null as the value always, rather than return value that might have actually come from a function. We're just returning null because it's a procedure. And I was having a little bit of an issue with running the simulations on my computer. day where for some reason I've just been having an issue and they were running super slow, even my assignment 3. So I'm just going to end the demo here.